Hey, good morning everybody. Bobby Watts here from Watts Innovations, bringing you a project highlight. Super happy to be bringing this one to you. This is so cool. I've been literally working on this for over 2 years, and I'm very happy to just publicly talk about it. It's been so long. So a few years ago, a company called Aergility came to me from the Central Florida region, headed up by Larry Young and Jim and Tim Vandermeer. And they had a concept that's not a new concept. They wanted to make a multi-rotor that could vertically take off, but could get hundreds of miles worth of flight and fly for hours. So I said, okay, I've heard this before. People have tried. Some people have not done very well with it. What's your solution? And they explained the concept to me, and I admit I was skeptical at first, but we've been flying their quarter scale model that I helped them develop, and it works. The physics are sound. It really works. It's so cool. So check this thing out. They call this their Atlas aircraft. Now this is a rendering of a full-size aircraft that they intend to build for mainly cargo hauling, moving cargo from point A to point B. And this aircraft here weighs, I believe it'll weigh about 800 pounds, can lift 300 to 400 pounds worth of cargo, and fly for hundreds of miles all in a single tank of fuel. So this is what they ultimately want to build. But in order to test their physics and to test that the concept actually works, what they did was they hired me to build a quarter scale model. So we built this guy right here. It's got 28-inch propellers. It's an X8 configuration. And the way it works is that it has a pusher propeller on the back. And this is the magic. When the aircraft takes off, it vertically takes off just like a normal multi-rotor. Once the gasoline pusher motor engages and the aircraft gets up to around 60 or 70 miles per hour, the power that's required for the main lift motors is substantially reduced because the pusher motor is generating thrust just by the aircraft flying forward. And they call this managed auto rotation. So for all my heli guys out there, we know what an auto rotation is, where we cut the power and just by the inertia of the aircraft and the air going over the blades, we actually create lift and we can keep flying even without the motor turned on. Same concept here. So the top motors get reduced to hundreds of RPM, very low. And the aircraft still maintains attitude and control. So super cool. We've been flying this thing a lot, actually getting a lot of flight time on it, and it works. I've seen the graphs, I've seen the proof is in the pudding. So it's a really cool concept. I was really happy to be a part of it. They had a very clear idea of what they wanted. I literally just helped them put it into real life, helped them put it in the computer model. We used SolidWorks, generated some really cool renderings, did some stress analysis, made sure everything was gonna hold up. And we fabricated this thing here in the US, built everything here, and they've been flying it for a few months now. So these guys are at the AUVSI show right now. They just launched, they're just promoting it now. So I wish them absolutely nothing but the best. You can head over to my YouTube page and see the full video of how it actually works, hear them talk about it. It's really exciting stuff. It's cool to be part of new technology that is moving us forward. It's just super exciting to be a part of it. So guys, wish you nothing but the best. Thanks for watching, and if you guys have any comments or questions about it, leave them here and I can forward them to them, or whatever you guys think. So what do you think about this? Do you think that this could be technology that could actually work? Is this going to be usable technology for us? I think it is. I think it solves the range problem that multi-rotors are plagued with. Really exciting, cool stuff. So thanks guys, thanks for watching, catch you next time.